You are welcome to this maths class. Now, let's look at this question. We want to express this function of x in terms of partial fractions. This is an algebraic term. This is another algebraic term. This algebraic term is of second degree. The one in the denominator is also of second degree. And what we must ensure is that the algebraic term or the polynomial above should be of degree lesser than that of the algebraic expression in the denominator. And therefore, something must be done to this to achieve that. Now, in our elementary class, you know that if you have something of this nature and you want to make the numerator lesser than the denominator, what you will do is you will divide. You say 5 divided by 4 is equal to 1, then remainder 1. And don't forget that this is the same thing as 1 plus 1 over 4. So, which means what you have when you divide 5 by 4 is 1, then plus the remainder divided by the divisor. So, the same thing we do here. We want to see what we get if we divide this by this. Then we now add it to remainder divided by divisor. So, all right. This divided by this. That is denominator divided by the denominator. Now, if you look at it, they are of the same degree. So, you have one of this. So, multiply this one by all this. 1 multiplied by 3 is 3. Then you have your minus. 1 multiplied by 2x is 2x. Then you have your minus. 1 multiplied by s squared is s squared. Then you subtract to get the remainder. Now from x squared, remove s squared. That is 0. 3x minus 2x. That's 5x. Minus 10 minus 3. That's minus 7. So this is the remainder. Which means what you have is 1 plus the remainder all over divisor. So this is what you have from here. So instead of writing all this, this is what we are going to write. So this rational function has been transmuted to this. So you have 1 plus 5x minus 7 all over s squared minus 2x minus 3. Now, we now break this one into partial fraction. The question you will ask yourself is that this, can it be factorized easily? Yes, it can be factorized easily. So let's factorize this denominator. So what we do is just multiply. This is 1. The coefficient here is 1. 1 multiplied by 3. 3s squared. So you have 3s squared for this. Now break this one down into 2 factors. You can say this is 3x multiplied by x, or x multiplied by 3x, as the case may be. So you are broken down into 2 factors. Now you ask yourself this question: what can I do to 3x and x in such a way that if I add them or subtract them, they will give me minus 2x? So what I can do is just put plus here, then put minus here. So minus 3x plus x is minus 2x. So replace this minus 2x by all this. So let's do that. Let me use this first, plus x minus 3x, then minus 3. So I can now factorize this x into s, okay, plus 1. Then minus 3 is common. Okay, so this is x minus 3. So this is the factors, these are the factors of this one. So let me replace this one with this one. We are going to ensure that we break them this one down into partial fraction. So you all right. So here, what we now have is we want to break this one down into partial fraction. We have a all over x minus 3, then plus b all over x plus 1. Now, don't forget that when you have, in our elementary class, when you have something like this, 1 over 3 plus 1 over 2, or let's say 1 over 3 plus 1 over 2, then you find the LCM. The LCM here is 6, as if you say 3 multiplied by 2, 6. So you get the LCM, and then you begin to divide the LCM by this. So the same thing here. Our LCM for this is this one multiplied by this one. So you can put it this way, x so this is our LCM. Now we begin to now divide the LCM by the denominator here. If you divide this one by this one, it means x minus 3 will cancel. We have x plus 1. So you have x plus 1, then you have your a plus the same thing here, s plus 1 will cancel. You have x minus 3. So once you divide, you multiply by a, you have this. You divide this, you multiply by b, you have this. So what you have now is this. You now observe here that this x minus 3 into bracket, x plus 1 into bracket is the same thing here. So the denominator is the same. So if this and this are the same, then it means this, 5x minus 7, and these ones are the same. So you now say 5x minus 7 is equal to this. So they are the same. Now the next thing to do is to find out what will be the value of A, what will be the value of B. And once we get the value of A, the value of B, we now replace them here. For you to get the value of A, you work on B. For you to get the value of B, you work on A. So let's get the value of B, and then we will now have to work on A. Now you set this x in such a way that the value here will be 0. What can you put here to make this value 0? Now if you put 1, 1 plus 1 is 2. It does not make this one is 0. 2 times A is 2A. So if we put minus 1 plus 1 is 0. 0 times A is 0. So let's put S, set x to be, set x to be minus 1. So let's put minus 1 here. Minus times 5, minus 1 times 5, that's minus 5. Minus 5, minus 7, that's minus 12. So if we put minus here, it will be 0, 0A. So then you have 0 plus, put minus 1 here, minus 1, minus 3, minus 4. So you have minus here, you have minus here. So divide both sides by 4. Your B is 3. So let's put that one somewhere. Our B is 3. So that's the first thing. Now let's now look at how do we get our A. If you want to get A, then you work on B. You will set your x in such a way that what we have here is 0. Already this is minus 3. If you put 3 here, 3 minus 3 is 0. So you set your x to be 3. Set your x to be 3 to get A. So let's put 3 there. 5 times 3, 15. 15 minus 7, that is 8. Now, this is 3 plus 1, 4. You have 4a. 3 minus 3 is 0. So our a is 2. You divide both sides by 4. So let's put that one here. Okay? The work is nearly done. You now come back here. What you now have finally is 1 plus this one has been broken down into this. Your a is 2. 2 all over x minus 3. Then plus your b is 3. 3 over x plus 1. So this is the final answer. So that function x, that rational function, can be broken down into 1 plus 2 divided by x minus 3 plus 3 divided by x plus 1. So this is where we are stopping until we meet again in another class.